This is a key to topic 19, part C. And in part C, you're given functions. And in our case, in this particular worksheet, it's either a polynomial function or a rational function. And you're asked to determine the domain. And you want to put the domain in interval notation. Okay, so again, we're only dealing with whether the function's a polynomial or whether the function is rational. Now, when we look at number one, just remind yourselves about what you learned in the lessons. So if we look at number one, you have f of x is 3x minus 2. Well, we know that that's a linear function. And so it's a linear function. We know the slope here is 3, so that's positive. So I know that my line's going to rise. And so remember, when you have this line like this, your domain is going to be from negative infinity to infinity. And in fact, one of the things you learned was that all polynomial functions have domain of all real numbers. Have domain all real numbers. Okay, that's what you learned. Okay, so here you're going to say negative infinity to infinity. All right, so negative infinity to infinity. In number two, this is also a polynomial function. In fact, it's a quadratic function. And so you know that the graph, now you don't know what the graph of this specifically is, but you do know that it's a parabola, right? And so it looks something like this. And so again, it's from negative infinity to infinity. So negative infinity to infinity. And remember, all these are polynomial functions. So remember, that's a polynomial function right here. So polynomial function. Okay, this one as well. All right, now, when we look at number three is not a polynomial function. Number three is a rational function. So h of x equals 5 divided by x minus 7. So remember, that's a rational function. And one of the things you learned was that when you look at a rational function or expression for that matter, you cannot divide by 0. You cannot divide by 0. So you got to find the restriction. So the restriction for that one, you got to find out what makes this denominator 0. That's easy to see. 7 makes its denominator 0. So the restriction is that x cannot equal 7. Once you find your restriction, here's what you learned. Well, you're going to put that in on your number line, and you're going to cross it out. And so now you have two intervals. So you're going from negative infinity to positive 7, parentheses, union, and then from 7 to positive infinity. So notice in parentheses here because 7 is a restricted domain. All right, so you cannot use 7, so that's why you see parentheses. All right, now we haven't talked about the graph of this looks like, but that's not necessary. All you had to know was that was a rational function, and so you have to find the restrictions. So what makes the denominator 0? So 7 makes the denominator 0. So you put that in a number line, cross it out, and so now you have two intervals. You have two intervals, negative infinity to 7, parentheses, union, parentheses 7 to infinity. Okay? All right, so that's number 3. So remember, number 3 is a rational function. And so you get negative infinity to 7, union, and then 7 to infinity. Number 4 is polynomial, so the domain's all real numbers. Okay, so that's polynomial function. Number 5 is rational, so let's talk about that. Number 5. So number 5, you have k of x equals x plus 2 divided by 2x minus 5. So again, in a rational function, so this is rational, so that's a rational function. So you got to look at the denominator, and you have to ask yourself, where is this equal to 0? So you just solve this linear equation. So 2x equals 5, so x equals 5 halves. So my restriction, the restriction is that x cannot equal 5 halves, because when x is 5 halves, I get a denominator 0. 2 times 5 halves is 5. 5 minus 5 is 0. So once I find the restriction, there's only 1 here, so that's the easy kind when there's just 1. Once I find it, I put that on the number line, 5 halves, and I cross it out because I cannot use it. So my domain would be any other number except 5 halves. So then you're going to say negative infinity to 5 halves, parentheses, union, and then 5 halves to infinity. Okay, so that's number 5. So remember, number 5 was rational. And so you get negative infinity to 5 halves, union, and then 5 halves to infinity. Notice the parentheses. There are no brackets because you cannot use 5 halves. 5 halves is not part of the domain, so that's why you don't see brackets there. Okay, number 6 is also a rational function. Number 6, we have this in number 6. We have f of x is equal to 7 divided by x plus 2 times x minus 5. Okay, and so this is already being factored for you. So it's a rational function. So this is rational, so that's a rational function. And so we got to find the restriction. So let's set this equal to 0. X plus 2 times x minus 5 equals 0. And remember, you have a product at 0, so we have to set each one of these equal to 0. So x plus 2 equals 0, x minus 5 equals 0, and so I get x to be negative 2 here, and when I solve for x here, I get x to be 5. So my restrictions is that x cannot equal negative 2 or 5. Once you find the restrictions, you put that in the number line. Now notice now there are 2 of them, and you put them in the correct order. So negative 2 is smaller than 5, so that goes here, and then 5 goes here. And then I cross those out. So now notice that these 2 numbers divide the number line into 3 intervals. And so when I write my domain in interval notation, I have 3 intervals. So I go from negative infinity to negative 2, parentheses, union, and then negative 2 to 5, parentheses, union, and then from 5 to infinity. And so that's your domain. So my domain will be all real numbers except negative 2 and positive 5 because that makes my denominator 0. All right. So in fact, if you look at all these are now going to be rational functions. So those are all going to be rational functions all the way down. So negative infinity to negative 2 union negative 2 to 5 union 5 to infinity. Okay, let's look at number 7. Number 7, we have a rational function. We have h of x equal negative 3 divided by x squared minus 16. So what you want to do there is go ahead and let's go ahead and factor the denominator. And so when I do that, I'm going to get, that's the difference of 2 squares. So I get x minus 4, x plus 4. And so right away, you know the restrictions. Even if you didn't, you just said each one equal to 0. So you'd say x minus 4 times x plus 4 equals 0. And so since I have a product that's 0, I got to set each one of these equal to 0. And so when I solve for x for each of those equations, I get x to be 4 and x to be negative 4. So the restrictions here would be that x cannot equal 4 or negative 4. Okay? Kind of makes sense. Since now you do notice that you could have looked at this right here and determined what the restrictions were. 4 squared minus 16, 0, and then negative 4 squared minus 16, 0. So you really didn't have to factor, although you could have. All right, and then you get your restrictions. Once you get your restrictions, notice there are 2 of them, just like there were 2 here. You put those on the number line, and make sure you put them in the correct order. So negative 4 goes first, positive 4 goes second. So negative 4 is less than 4. Cross them out, because if you didn't have them in the right order, then your domain will be incorrect. Notice now that, again, there are 3 intervals in my domain. I cannot use negative 4, 4, because that makes my denominator 0. So my domain then will be negative infinity to negative 4, union negative 4 to 4, no parentheses, union 4 to infinity. All right, so that is number 7. Number 7, negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. All right, number 8. Okay, so number 8, I want you to remember something about number 8. Number 8 throws students off a little. And so number 8, we have h of x equals -3 divided by x squared plus 16. So notice in number 7, the denominator was x squared minus 16. Now we have x squared plus 16. Well, what I want you to remember is that this is the sum of two squares. Remember, you cannot factor that. And so if you ask yourself, well, then how can I determine the restriction? Well, what's going to make this denominator 0? What makes the denominator 0? What makes x squared plus 16 equal to 0? What real number? What real number? Well, there are no real numbers. There are no real numbers there are no real numbers in which x squared plus 16 equals 0. You may say, well, why not -4? Because remember, -4 times itself is a positive 16. 16 plus 16 is 32, not 0. All right. So since there are no restrictions, the domain is all real numbers. Domain's all real numbers. No restrictions. There were no restrictions. Your domain's all real numbers. All right, so that one's -infinity to infinity. Number 9, we have g of x is equal to x plus 8 divided by 2x squared minus 7x minus 15. So let's go ahead and factor this. So when I factor this, I'm going to get, let's see, I'm going to get 2x x. Let's put well, I wonder if I wrote this correct. Let me check. Okay, so yeah, I did. I wasn't thinking very well. So let's put this as 5 here. And let's put this as 2. So that's going to be 10x. That's going to be 2x. Oh, that's 3 rather. Okay, 3 because I need 15. So that'll be 10x, 3x. So that's going to be that 7. But I need to be -7. So that means the 5 has to be negative and the 3 has to be positive. Okay. All right, now once I factor the denominator, I got to find out what makes these factors equal to 0, because that's going to make my denominator 0. So I said each one equal to 0, and it's just the denominator, because remember, it doesn't matter if the numerator is 0, it's the denominator. You cannot divide by 0. So 2x equals -3, so x is -3 halves. Over here, x is 5. All right, so let's put that on the number line in the correct order. So I have -3 halves, and I have 5. And I'm going to cross them out because I cannot use them. That's not part of my domain. But if I substitute -3 halves into here, I'm going to get 0 in the denominator. Does not matter what the numerator is. It's your denominator. Remember, you cannot divide by 0. Same thing here. If I put 5 here, this is 5 minus 5 is 0. So whatever these are, I get 0 in the denominator. All right, so I have 3 intervals. So I'm going to say -infinity to -3 halves, union -3 halves to 5, union 5 to infinity. So that's the answer to number 9. So number 9, we have -infinity to -3 halves, union -3 halves to 5, and then union 5 to infinity. All right. And then in number 10, we have k of x is equal to x plus 2 divided by 3x. Even though this looks simple, some students get thrown off by this as well. So notice my denominator is just 3x, right? So where is that equal to 0? Again, it does not matter what the numerator is. You always look at the denominator. Well, that's equal to 0 when x is 0, correct? So the restriction is that x cannot equal 0. So you put that in a number line. Kind of makes sense because what's 3 times 0? 0. And cross it out, so you just have 2 intervals, and so you get -infinity to 0, union, and then 0 to infinity. And so that's the answer to number 10. So -infinity to 0, union, and then 0 to infinity. Okay, so that is the key to topic 19, part C.